AI seems to be everywhere, doesn't it? I mean, from your phone suggesting replies to really complex financial modeling, it's becoming essential. But, if you're looking for that real competitive advantage with AI, it really just boils down to one thing: data. The more data, the better the quality, the more diverse it is, well, the smarter your AI gets. But, and this is a big but, actually getting access to enough of that good data. That's incredibly tricky, isn't it? You've got privacy concerns, complicated compliance rules, and just finding those really unique, valuable data sets is tough. So our mission for this deep dive, really, is to explore this fascinating solution that tackles these data challenges head on. It's called Federated Machine Learning. It's all about how you can get more from your data powerfully, ethically, without, actually compromising privacy.
Exactly. I mean, that's the fundamental challenge for so many companies, right? To make their AI systems truly outperform the competition, they need that diverse, extensive, high-quality data. But often that data lives somewhere else outside their direct control. And things like strict privacy rules, or sometimes even just internal company walls, they limit the ability to use those really relevant data sets. It's a major roadblock in the AI race. And this is precisely where federated learning comes in as, well, a potential game changer. It basically lets an AI model, an algorithm, get trained using data from lots of different places, decentralized servers, often run by totally different organizations. The core idea, the kind of revolutionary insight here, is that you're sending the algorithm to the data rather than sending the data to the algorithm. That's the key shift. And to make this even more secure, the process often gets combined with some pretty sophisticated encryption techniques like multi-party homomorphic encryption.
Okay, homomorphic encryption.
Yeah.
That sounds complex.
Yeah, it sounds fancy, but you don't need to be a cryptographer to get the gist. It essentially lets calculations happen on encrypted data. Think of it like being able to add up a list of numbers without ever actually knowing what the individual numbers are. The data stays private, totally secure, even while the AI is learning from it.
Okay, that makes sense conceptually. But let's ground this a bit. How is federated learning actually being used right now? Like in the real world, can you give us some impactful examples?
Absolutely. One of the really compelling examples is a collaboration between Zurich Insurance Group and Orange, the big telecommunications company. So Zurich needed to seriously improve a predictive algorithm for their insurance business. Using a commercial federated learning platform, they basically trained their algorithm using Orange's huge customer data set. But here's the crucial part. Orange never had to release any of that data. Not a single piece left their servers. The result for Zurich: a massive 30% improvement in their AI systems predictions. That directly translated into a significant revenue boost for them.
Wow, 30%, that's huge.
It really is. And for Orange, it opened up a completely new, totally ethical way to monetize their data assets while keeping client privacy absolutely locked down.
Okay, that 30% jump is incredible. And it makes perfect sense for companies in different industries like insurance and telecoms. But what about the elephant in the room? Can direct competitors ever actually use this to collaborate ethically? That feels counterintuitive.
Yeah, it might seem that way, but yes, absolutely. We're actually seeing some really powerful intra-industry collaborations happening now that were pretty much unthinkable before. Think about competing pathology departments in different private hospitals.
Okay.
Individually, they've always struggled to gather enough data to train really robust diagnostic AI. Why? Because, rare diseases or specific conditions just don't show up often enough in any single hospital.
Right, not enough samples.
Exactly. But through federated learning, they can now train a shared diagnostic algorithm. They combine their data, say, images of tissue samples for disease analysis, without ever actually pooling the raw images in one place. And this leads to much, much higher performance for the AI. It provides invaluable, potentially life-saving insights for all the participating hospitals, insights that none of them could have reached on their own. And this also sparks a totally new business model, which kind of reshapes how we think about intellectual property and value in AI. You can actually determine ownership shares in this collaboratively developed, collectively owned algorithm based on how much data each hospital contributed.
Interesting.
Yeah. And then this jointly owned algorithm, it can be commercialized, it can be rented out to third parties, and the revenue gets shared based on those ownership percentages. It sort of democratizes AI development, right? It allows smaller players to contribute to and benefit from advanced models that were maybe only accessible to the tech giants before.
That's a really different way of thinking about it.
It is. And another great example is in finance among competing banks. By using federated learning combined with that multi-party homomorphic encryption we talked about, banks can securely check if a potential client has been flagged as problematic by a competitor.
Without revealing who the client is.
Exactly. Without revealing any specific client information at all, this drastically cuts down the huge costs tied to know your customer or KYC processes. I mean, those KYC costs currently eat up something like 3% of global banking operational costs. So reducing that is huge, and it makes the whole customer onboarding process much smoother.
Okay, so federated learning can bridge gaps between different companies, even competitors, creating new value. That's clear. But what about within one really big company, say a global corporation with data scattered all over the place in different divisions or countries? Can it help unlock data that's siloed inside the organization?
Oh, absolutely. That's actually a really crucial application too. Federated learning definitely helps break down those internal data sharing barriers. Think about all the hurdles. Compliance issues, ethical restrictions, maybe data sitting in different legal entities or across different countries with varying laws. All these things can make it almost impossible for one part of a large company to access data held by another part. This approach lets different groups leverage data the company already owns but couldn't previously access, unlocking its full value without messing up internal policies or crossing legal lines.
That's fascinating how versatile it is. Okay, so for someone listening now, maybe thinking, right, how could we use this? The practical question becomes, how do you even start? How do you figure out who the right partners might be? What kind of data should you have, or what should you look for in a potential collaborator?
Yeah, that's key. The critical things you need are data complementarity and volume. For AI training to be really successful, you generally need two things. A large number of samples, think individual clients, patients, insurance policies, that sort of thing. And you also need a good number of features or variables for each of those samples. These are the two main dimensions where federated learning really helps organizations grow their data's power.
Okay, samples and features. Can you break that down a bit more?
Sure. Think of it like a spreadsheet, maybe. The samples are your rows, each individual person or item, your clients, your patients, whatever it is you're analyzing. And the features, those are your columns. All the different bits of information you have about each sample, their age, maybe purchase history, location, medical readings, you name it. And this leads us to the two main sort of flavors of federated learning. First, there's horizontal federated learning. That's all about increasing the number of samples, the rows that the model gets trained on. Second, you have vertical federated learning. This is about increasing the number of features, the columns that the model analyzes for each sample it already has.
Right. And I guess before you even think about collaborating, you need to figure out what your own data actually looks like along those lines. Where do you stand now?
Precisely. You need to understand the quality and structure of your existing data. That tells you your starting point and where you need to go. We can broadly categorize data into 4 types based on those samples and features. First, you might have poor data. That means you've got a low number of samples and a low number of features. You're kind of starting from scratch data-wise.
Okay.
Then there's vertical data. Here, you have a large number of samples, lots of rows, but relatively few features per sample, not many columns. Imagine maybe you run a huge online store. You have millions of customers. That's tons of samples. But perhaps you only collect basic purchase info and their location. Lots of who, but not much what else about them. This data benefits most from vertical learning to add more features to become richer.
Got it. So what's the opposite?
That would be horizontal data. This is where you have a small number of samples, not many rows, but lots of features for each one, many columns. Maybe think of a specialized medical clinic. They might have deep, incredibly detailed histories for a relatively small group of patients, lots of detail, but on fewer individuals. This type benefits from horizontal learning, adding more samples to become richer.
And the last one is the goal, I assume.
Exactly. Rich data. This is the ideal state. You have both a large number of samples and many, many features for each sample. You're basically sitting on an AI goldmine.
Okay, that makes sense. But you mentioned complementarity earlier.
Right. And that's a really important caution. Simply going from poor data to horizontal or vertical through collaboration might not actually improve your AI's performance much if the new data doesn't add the right kind of complementary information. For instance, a hospital could get more vertical data by adding lots more patients from another hospital via horizontal federation. But if those new patients don't come with new relevant features, new types of medical readings or history, the diagnostic AI might not get any better. It needs meaningfully different information, not just more of the same kind.
Okay, so you need the right kind of addition, not just any addition. So how do you figure out where your own organization stands? Which of those 4 boxes are you in? And then how does that guide finding a partner?
You need to assess your data along those two dimensions we talked about. For the vertical dimension, the samples ask yourself, are all the important segments of the population or the reality we're trying to model represented in our sample? If the answer is generally yes, your data probably leans towards being vertical, large sample. For the horizontal dimension, the features ask, are the variables, the data points we have about each observation enough to really explain its behavior or predict outcomes? If yes, then your data leans horizontal, many features. If you answer yes to both, you've got rich data. No to both, that's poor data.
Okay, and this self-assessment, this is where the strategic power really comes in, right?
Yeah.
Once you know your data type, it basically points you towards a clear strategy for collaboration.
Exactly right. It becomes your roadmap. If you determine you have vertical data, meaning lots of samples but not enough features, you should strategically look for collaborations outside your own industry. The Orange Zurich example illustrates this perfectly, right? Orange had telecom data communication patterns, mobility. Zurich had insurance data risk profiles, consumption habits, maybe for some of the same people. Different services meant different complementary features for the same set of samples. They needed more columns.
Right, different angles on the same customer.
Precisely. Now, if your assessment shows you have horizontal data, meaning not enough samples, but lots of features for the ones you have, your strategy flips, you should look for collaborations within your industry. You need more samples, more rows to make your rich feature set statistically powerful. That's exactly what we saw with the competing pathology departments combining patient cases or banks potentially sharing anonymized client flags. They need more examples.
Okay, vertical goes outside, horizontal stays inside. Makes sense. What if you're starting with poor data?
If you're starting with poor data, the first most critical step is what we might call datafication. You need to start intentionally recording data, turning observations and interactions into structured, usable data points that an AI can actually learn from. But, and this is key, do it strategically from the start. Think about what kind of data would be valuable and complementary to other organizations you might want to partner with later. Aim to record data that could enrich their vertical or horizontal data sets down the line. Build towards future partnerships.
So even from a poor starting point, you can be strategic about where you want to end up. And what about if you're lucky enough to already have rich data?
Well, if you're sitting on rich data, first off, congratulations. You're in a fantastic position for developing powerful AI internally. But federated learning still offers a huge opportunity, just a different kind. You can actually monetize your valuable data asset. You can contribute your rich, anonymized data to help train external AI systems, other companies' algorithms, all while maintaining complete ownership and control. Your data never leaves your site. A great real-world example of this is the Mayo Clinic's Solutions Studio. They offer access to global, federated, de-identified health data specifically for this purpose, creating a new revenue stream from their rich data asset.
Wow. Okay, so reflecting on all this, what really stands out to you from our deep dive today? For me, it's really that federated learning isn't just some, technical fix for privacy. It's actually a strategic pathway. It unlocks insights we couldn't get before, enables totally new business models like that shared algorithm ownership, and it does all this while keeping privacy absolutely central, it feels like. Collaborative intelligence, but done right.
I think that's a great way to put it. If we connect this to the bigger picture, it really highlights something fundamental about the future of competitive AI. It's not just going to be about having some data or even a lot of data. It's going to be about intelligently leveraging complementary data from diverse sources and doing that without ever having to physically pool it or give up control. That's the paradigm shift. And this really raises an important question for everyone listening, I think. How might understanding these four types of data, poor, vertical, horizontal, rich, major, how might that fundamentally change the way your organization approaches its entire data strategy and thinks about collaboration in the years ahead? It's almost like having a strategic compass in this complex AI landscape, It points you directly towards the partnerships that can unlock truly exponential growth, not just small, incremental improvements.
We sent the algorithm out to the data, and it definitely brought back some incredible insights for us today. Now, it's really over to you, the listener, to explore what this all means for you and your own data journey.